Hey everybody, Daniel here from Basement Tech. What you see in front of you are some lithium ion cells, specifically the ubiquitous 18650 cell that's used in all over the place in most laptops around the world. Battery packs are built up from these individual cells, and that's what we're going to do here. I've wanted to learn more about how these things work for quite some time, but I thought to maximize learning I should pick a specific application. I'm also into ham radio, and so this application seems kind of natural. I've built up kind of a collection of these Motorola MT-1000, call them walkie-talkies. We in the hobby call them transceivers, handheld transceivers. The radios themselves are indestructible, and I've had these for many, many years. However, the battery packs themselves are kind of obsolete and made out of NiCad or nickel metal hydride and are very, very costly at this point. So I wanted to see, can I use these cells to build up, call it a proof of concept, to maybe an ugly proof of concept battery pack that I could use with these radios. Let's go back to the cells themselves for just a minute. These cells, as I said, are the 18650 cell. They have a nominal voltage of about 3.6 volts. However, when charging, they go up to about 4.2. They have a stated capacity of 3,300 milliamp hours and probably a minimum voltage, it looks like from the curves, of about 2.5 or just a little bit lower than that voltage. The amazing part to me is they have a stated maximum current draw of 10 amps. I'm not going to get anywhere near that with this application, but it's just amazing to me that it can be that high. So for this application, we need about 9.6 volts, which harkens back to a NiCad pack. At about 1.6 amps, let's just call it 2. These batteries are very naturally made for that application, and I think it'll work out well. In addition to the cells themselves, I needed some way to kind of hold them together, so I purchased these little battery holders. Some people will use spot welders or other methods to join these cells into a pack, but I thought this would be a good way for experimentation. To reach 9.6, we need to connect 3 of these batteries in series. Now, lithium-ion cells require a small device called a battery management system. It's way smaller than the big giant title would suggest, and here's an example of the ones I used. This is actually 2 copies of the battery management system. They're very, very cost effective at this point because, as I say, everybody's using those cells. These, I think, were in the neighborhood of $2.50 each. Given that small price, they really do perform quite a lot of functions. The primary function of the battery management system is to ensure that all of the cells in the pack are maintained at about the same voltage when charging and discharging. You can see on this little battery management system, and remember this is 2 copies of the same thing, there are many little electrodes. Essentially what the battery management system needs is the voltage of each individual cell such that it can do that management function that I mentioned. So there you see at the top B1, B2, B+. Those are the intersections of the 3 cells that are in series. The input and output for charging and discharging are on the right, the P- and P+, and the main ground is there at the bottom, B-. In addition to that balancing function that I mentioned, this particular one also does over current protection, over voltage protection, over discharge or under voltage protection, and only draws about 6 microamps when no power is being drawn. So it's essentially invisible when no power is being drawn. Well, through the magic of the internet, we're going to fast forward, and I'm going to show you kind of the finished prototype, if you will. Here you can see I did stick with that sort of ugly proof of concept theme. The circuit board on the back is just the substrate I had onto which to screw the 3 battery holders. Once I did that, you can see those red wires achieve the 3 cells in series, and then the BMS is mounted on top. You might remember each of the cells needs to have its voltage sampled, and that's why there are 3 connections to the top of the BMS. Finally, switching to kind of a front view, you can see that it looks a lot less ugly from the front, but it's completely functional. We now have a battery pack, so how are we going to charge it? We'll enter this little device. It's called the D-Rock buck converter. As I say in lots of my videos, I don't like to repeat all of the other videos all over YouTube. There are many videos on how to use a device like this to charge lithium-ion batteries, so I'll just provide a quick summary. I chose this little device because it has the ability to regulate a voltage down from to a preset level. It has a constant current mode, which is the first phase of charging lithium-ion batteries, and a constant voltage mode, which is the second phase. It has ample capability. It can take in 6 to 32 volts and output, again, to a preset level, 1.5 to 32 volts. Finally, a use for one of those old laptop power supplies that I've been hoarding, giving way to a front view of the first power-up of the D-Rock buck converter. Okay, well, I'm going to leave this video here and give you just a quick glimpse of where we're going with this next picture. As always, if you like this kind of video, give it a thumbs up and subscribe to the channel. And I'll talk to you next time, where we'll put this all together into a form factor that makes sense for that MT-1000 handheld transceiver.